In this video, we're going to review some trig concepts from previous courses. So the first concept is primary trig ratios. So given a right triangle, there are three primary trig ratios you may have encountered: the tangent ratio, the sine ratio, and the cosine ratio. Recall that the tangent of an acute angle is an angle less than 90 degrees, is equal to the length of the side opposite the angle over the length of the side adjacent the angle. Or what we could say, tan of A is equal opposite over adjacent. The sine ratio of an acute angle is the length of the side opposite the angle divided by the length of the hypotenuse. And the cosine ratio is the length of the side adjacent the angle divided by the length of the hypotenuse. So for example, if we're focused on angle A, then BC is the side opposite angle A. AC is the side adjacent angle A. And AB is the hypotenuse. If we are focused on angle B, then AC would be the side opposite angle B. BC would be the side adjacent angle B. And AB would be our hypotenuse. So therefore, if we wanted to determine the sine ratio for angle A, that would be equal to, remember that's opposite over hypotenuse, so that would be BC over AB. If we wanted the cosine of angle A, that would be the adjacent over the hypotenuse, so that would be AC over AB. And if we wanted the tan of angle A, that would be equal to BC over AC. To determine the sine, cosine, and tangent of angle B, pause the video and then check your work. So the sine of angle B would be AC over AB. The cosine of angle B would be BC over AB. And the tangent of angle B would be AC over BC. Next up are special triangles. So we use our special triangles to help us determine ratios or angles without a calculator. So our first special triangle is a isosceles right triangle. So isosceles means two sides are equal in length. If the legs have length of 1 and 1, then using Pythagorean's theorem we can show that the hypotenuse has a length of root 2, and that the acute angles in this triangle must both be 45 degrees. So with this triangle, for example, we could determine the sine of 45 degrees. And the sine of 45 degrees would be opposite over hypotenuse. So here's our angle, 45 degrees. This side is opposite 45, and root 2 is the hypotenuse. So therefore we get 1 over the square root of 2. Or you may also see it expressed as root 2 over 2. So if you take 1 over root 2 and multiply it by root 2 over 2, which is equal to 1, then 1 times root 2 is root 2. Root 2 times root 2 is the square root of 4, which is equal to 2. Next up is the special triangle determined from an equilateral triangle. An equilateral triangle will have angles of 60 degrees. And let's say all the side lengths are 2. If we split this triangle in half, we get our second special triangle. So we still have the 60 degrees in the bottom right. Since we split it in half, the top angle is 30 degrees. The hypotenuse is still 2, and again, since we split it in half, the base is now 1. And the third side, using Pythagorean's theorem, will be the square root of 3. So again, using this triangle, let's say for the sine of 60 degrees, so here's our angle of focus, then this would be opposite 60, and this would be the hypotenuse. So the sine of 60 degrees is equivalent to the square root of 3 over 2. If I wanted the tan of 30 degrees, then here's my angle of focus, and now this is my opposite side, and this will be my adjacent. So tan of 30 is equivalent to 1 over the square root of 3, which again can be expressed as root 3 over 3. And we can determine any ratio using 45, 60, or 30 with these special triangles. Next up is trigonometry in the xy plane. So example 1, sketch each angle in standard position. All that means is we're going to start from the positive x-axis, and that's going to be called our initial arm. And then we're going to rotate counterclockwise our rotation angle. So in this example is 60 degrees, so we're going to rotate 60 degrees, and that will give us the terminal arm's location. So next up is 420. So again, starting from the positive x-axis, we're going to go full 360. Then we need 60 degrees more into quadrant 1. So there is 420 degrees. Notice we had to travel 60 degrees into quadrant number 1. And finally, negative 300. Negative 300 would go clockwise until we get back into quadrant 4. So there's negative 300 degrees. And once again, notice that if we were to go counterclockwise, this would be 60 degrees. So all these terminal arms end up in the same location. And when that happens, we have what are called coterminal angles. Coterminal angles are angles that have all the same initial and terminal arms. Our next definition is a principal angle. A principal angle is an angle formed by a counterclockwise rotation and must be between 0 and 360 degrees. So let's look at how to determine a principal angle. So starting with negative 210. So remember that's a clockwise rotation, and this will be into quadrant number 2. The principal angle is the one that rotates counterclockwise, starting from the positive x-axis. And we can see our principal angle in this example would be 150. And I determined the value of 150 by taking 360 and minusing 210. The next one is 420, so that means we do a full 360 and then again 60 back into quadrant 1. So remember, the principal angle is the counterclockwise rotation between 0 and 360, so here is our principal angle right here. In this case, our principal angle is equal to 60 degrees. Remember, we went 420 plus 60 degrees into quadrant number 1. And finally, 210. 210 takes us into quadrant number 3. And since 210 is between 0 and 360, and since we rotated counterclockwise, this is our principal angle. Next up is the related acute angle. And the related acute angle is the acute angle determined by the right angled triangle formed by the terminal arm and the x-axis. Keyword here does not say positive or negative, it just says the x-axis. The related acute angle is always positive. Since we're looking for an acute angle, we're always looking for an angle less than 90. So determine the related acute angle for the angles given in example 2. So let's go back up to example 2. So if I draw a right triangle attached to the x-axis, again, the keyword is the x-axis, then the related acute angle is this angle in here, which if I go negative 210, that's 180 plus 30, so my related acute angle is 30 degrees. Or if I look at it from the other way, the principal angle is 150, and to get all the way down to that x-axis, I need another 30 degrees. Let's go to the next one. If I draw a right triangle, I'm looking for this angle here, which again we see is 60 degrees. I have to rotate 60 degrees into quadrant number 1. And finally, the last one. We must connect it to the x-axis, so I'm looking for this angle here. And since we went 210, that's 180 plus 30. So the related acute angle is 30 degrees. Next up is what we call the cast rule. And the cast rule just tells you which ratios are positive in each quadrant. I like to remember it as all students take calculus. So starting with the A in quadrant 1, all students take calculus. So that means in quadrant 1, all of the primary trig ratios are positive. So again, this is called quadrant number 1. In quadrant number 2, only the sine ratio is positive. In quadrant number 3, only the tan ratio is positive. And in quadrant number 4, only cosine is positive. So that is what you might have called the cast rule. So example 4, given the point root 3 and negative 1. First, let's plot our point, root 3 and negative 1. So our terminal arm is in quadrant number 4. So let's draw our principal angle. So here is our principal angle. So we'll call this theta. And in grade 11, you would have looked at a new definition for sine, cosine, and tangent on a Cartesian plane. You would have learned that sine of theta is equal to y over r. Cosine of theta is equal to x over r. And tan of theta is equal to y over x. Now if you forget these, I always find it easy just to draw a picture of a right triangle. Imagine you're in quadrant number 1. And here's our point x and y. Well, we know that y is the height of this triangle, x is the base of this triangle, and r is what we call the radial arm. So imagine this is angle theta, then y is opposite angle theta, x is adjacent to angle theta, and r is our hypotenuse. So we can already find the tan ratio, but what we're missing is r for this. Because we have x and y, so here's our x, here's our y, we're just missing the length of this radial arm. If we go back to our picture, there's a formula to find this length. It's Pythagorean's theorem, x squared plus y squared equals r squared. So the length of the radial arm is r equals the square root of x squared plus y squared. So again, r is equal to the square root of root 3 squared plus negative 1 squared. Root 3 times root 3 is 3. Negative 1 times negative 1 is 1. So we get the square root of 4, which means we have a radial arm of length 2. So now we have everything to determine sine, cosine, and tangent. So for part A, the sine of this angle is equal to, remember it is y over r, so it's negative 1 over 2, because y is negative. Cosine of theta, well that's x over r, root 3 over 2, and tan of theta is y over x, so that's negative 1 over the square root of 3. Or we can write it as negative root 3 over 3. So let's go to part B. So part B wants us to determine angle theta. What would be helpful is if we knew this angle, which is called our related acute angle. It's the angle made with the x-axis. So what we can do for part B is find our related acute angle. And we can do that two ways. First of all, we can take the tan inverse, or the sine inverse, or the cos inverse of any of the three ratios, and always take the positive value. So I can take the tan inverse of 1 over root 3. I do not take the negative, so always use the positive. And if you type that into your calculator, you should end up with a related acute angle of 30 degrees. The second way we could have determined this is notice that we have a special triangle. If I was to take this and connect it to the x-axis, this side would be equal to 1, that's the y value. This side would be equal to root of 3, that's the x, which means the hypotenuse is 2. And this is our special triangle where this angle is 60 degrees and this angle is 30. And notice if I want the tan, so if I look at opposite over adjacent, so 1 over root 3, that means we're focused on this angle of 30 degrees. Now that we have the related acute angle, we can find the principal angle. So remember, our terminal arm is in quadrant number 4. Our related acute angle is 30 degrees. So if I want the principal angle, theta, that would be 360 degrees minus that 30 degrees, which tells us our angle is 330 degrees. And you can use your calculator to check. If you typed in sine of 330 degrees into your calculator, you should get negative 0.5. Let's go through a few more examples. So example 5, let's sketch theta equals 225 degrees. So we know that's going to be in quadrant number 3. So that's part A. Part B, determine the value of the related acute angle. Well, if we take a look at the angle it makes with the x-axis, so if we take 225 and minus this 180 here, we can determine this angle to be 45 degrees. So that's our related acute angle. So that's part B. Next up is part C. We can now determine the values of sine, cosine, and tangent using what are called equivalent expressions. So for part C, we want to find the sine of 225, the cosine of 225, and the tan of 225. So without a calculator, what we need to do is write this as an equivalent expression. So we base it upon the related acute angle. So the sine of 225 is equal to the sine of 45, but we got to decide, is that plus or minus? Same with the cosine of 225, it's equal to the cosine of 45 with either a plus or minus attached to it, and the tangent of 225 is equal to the tan of 45 with a plus or minus attached to the front of it. Well, how do we know? Well, since we're in quadrant number 3, who's positive? Quadrant number 3, tangent is positive. That means the other two are negative. So we put a negative in front of sine, a negative in front of cos, but we know the tangent is positive. Notice now we're dealing with 45 degrees. So without a calculator, we need to use a special triangle. So that's the 1, 1, root 2 triangle, which has 45 degrees in it. So here's our angle of focus. This side is opposite, this side adjacent, and this side hypotenuse. So the sine of 225 is the negative of 1 over root 2, or the negative of root 2 over 2. The cosine of 225 is equivalent to negative 1 over root 2, again, which is equal to negative root 2 over 2. And the tan of 45 is equal to 1 over 1, which is just 1. And our last example, determine the values of theta if theta can be between 0 and 360 degrees. Let's review how to solve trig equations. So there's just 3 steps you need to do. First of all, identify what quadrants you are in, determine your related acute angle, and then solve for your angles. So let's start with what quadrant we are in. So we see that it's given us a positive ratio. So sine is positive in quadrants 1 and quadrants 2. Next, we need the related acute angle. So the related acute angle is the sine inverse of the positive ratio 1 over root 2, which, if you recall, that is one of our special ratios. which tells us our related acute angle is 45 degrees. And then the third step is to sketch the two quadrants you're in. So quadrants 1 and quadrant 2. Draw the principal angles, and then determine their values. So theta 1 is our related acute angle, 45 degrees. And theta 2 we get by doing 180 degrees minus the 45, which is 135 degrees. Remembering that this is our related acute angle 45, so 180 minus 45 is 135. Let's do this one more time. So recall that tan theta is negative in quadrants 2 and quadrants 4. Next, we need to determine our related acute angle. So the related acute angle is the tan inverse of root 3 over 1, which again is a special triangle, which gives us an angle of 60 degrees. So this could be a no calculator question, and just to remind you, you would have to draw your right triangle. There's 60, there's 30, and there's your angle. 2, 1, and root 3. So here we see root 3 over 1. So that means that we're saying that this is opposite and this is adjacent. And for that to work, this has to be our angle. Now that we have the angle, we draw our two principal angles in quadrants number 2 and quadrants number 4. So there's quadrant 2, there's quadrant 4. Noting that this is 60 degrees here, this is 60 degrees here. And determine your angles. So theta 1 is going to be 180 minus 60, so that's 120 degrees. And theta 2 is equal to 360 minus 60, so that is 300 degrees. And again, you can always go back and check your work by typing in the tan of 120, the tan of 300, and you should get the same answer, which is equivalent to root 3 over 1. Try the following questions.